Okay, so the topic, this is the last lecture that deals with the skeletal system in general. You know, in the first three lectures, we talked through bones from a cellular standpoint. We talked through it from a tissue standpoint, cancellous and compact. Talked about bones from an organ standpoint, the different types of bones, and how the unique shape of a long bone gives it certain unique features. We've also now talked through all of the major types of joints. And the last thing we want to do here is talk about movement at the joints. Okay? Just brief review would give us, you know, that where two bones meet, there doesn't necessarily have to be any movement there. We're going to be talking about synovial joints here. There are three major types of joints. This is all review, right? And the synovial joints are the freely movable joints. So when we talk about movement, we're talking about the joints that are synovial. So we're going to focus here now. There are 6 movement terms, and you see these right there at the top of this joint list on your handout. There's 6 movement terms that we're going to focus on here. Some of them are opposites of each other, like this first pair that we want to describe are flexion and extension. Let's make sure that we have a real good picture in our mind of what flexion and extension are. Probably the easiest way to describe it is with this type of a picture where it shows you taking typically a hinge joint, but you can do it at other joints, and bending. The bending and straightening action would be a simple way to describe this. If you're bending a joint, then it's a flexing activity. If you're straightening, like if you're reaching out to shake somebody's hand, that's an extension activity. If you want to be sort of mathematical about it, if you look at the angle between the two bones where the flexion or extension is taking place, you can describe the number of degrees in an angle. Does everybody know how many degrees in a right angle? 90, okay. A straight angle is 180, okay. So you're all educated people, right? If you go from here to here, the number of degrees is getting smaller, isn't it? It's decreasing. 180, 170, 160, 150, up to 90, right? And keep going, 90, 80, 70, 60, 50. So a flexing activity would be described as the joint angle, the number of degrees in the angle is decreasing. And so obviously extension would be the opposite of that, wouldn't it? If the joint angle or the number of degrees in the angle between the two bones was getting larger, we would describe that as extension. Now, another thing to notice about flexion and extension is that these are anterior and posterior motions. Because if we're going to describe these motions technically, we want to use the anatomical position. You can put body parts in all sorts of funny angles, and you can do flexing and extending. Like if I'm doing flexing and extending here, I'm going side to side, aren't I? But that doesn't count in terms of our description. We want to be able to describe those motions from the anatomical position. And every flexing and extending activity from an anatomical position is a forward and backward motion, isn't it? I can talk about the angle at my elbow, flexing, extending, forward motion, backward motion. I can talk about it at my wrist. This is an ellipsoidal joint, but I can flex and extend with it, right? Flexing. If you look at the angle between my hand and my forearm, that's flexing, that's extending, isn't it? Make sense? And in the anatomical position, that would be a forward and a backward motion. I can flex and extend here with my fingers. right, in the anatomical position. The flexing, the joints angles are getting smaller, curling action, right? That's a flexing, and that's a forward motion. And the straightening of my fingers is a backward motion, posterior motion. So all of these joints, basically, when you're describing flexion and extension, are forward and backward, anterior and posterior motions. And it turns out that with only one exception, every flexing activity is the forward motion. In fact, that's the word, those are the two words I keep in my head. Flexing, forward. Right? Flexing goes forward. Right? Extension is the other. There is one joint in your human body that's built backwards, that's put on backwards. When you flex, the body part goes behind you. What? Yeah, your knee, isn't it? Right? When I flex my knee, right, it bends. When the angle between the two bones gets smaller, right, my leg and my foot are going behind me. So the knee is the only exception to this standard thing. Flexing is always forward, extending is always backward. Yeah, Joe. Okay. Now let's deal with some of the other. Right now we've just been talking about like elbows and knees and wrists and ankles and all of that. What do I do with my body? Well, typically the same thing. You have these pictures that illustrate these things, right? And here in this third picture, if you're bending from the waist forward, we're going to call that flexion, right? And if you were to lean way back, that's extension, right? Same thing with your neck, right? If I dip my head forward, that's a flexing. If I put it back, it's an extension. So again, this anterior-posterior thing helps a lot with the areas that might not be so obvious. In fact, the shoulder and the hip, these are the ones that confuse most people. Most people get the body forward, right? Because the angle between my torso and my legs, that angle is getting smaller, getting larger, right? The angle here is getting smaller, getting larger. Most people get that. But what do you do here? At your shoulder, I can move my arms so many different ways. Any motion forward is the flexing motion. Any motion backward is the extension motion. Same thing at my hip. Any movement forward with my limb from my hip is a flexing motion. Any movement backward from my hip is an extension motion. So if you keep the forward-backward concept going, it works everywhere except the knee. The knee is the only exception to this whole rule. But otherwise, and I think generally it's probably easiest to think if I'm dealing with the whole body, shoulder, hip, torso, head and neck, anything in the central core of my body, think forward, backward, anterior, posterior, flexing forward. And make sure you see the forward motion. If I move from here to here, what did I just do? If I'm moving from here to here, what did I just do? Is that extension or flexion? Went from here to here. It's not where my arm is, which direction is it going? It's going forward. This is flexion. Flexion can go from here all the way over to here, and then I'd be going backwards again, right? Extension can go from here to here, right? It's moving in that direction. That's an extension, okay? So I don't have to lean all the way back. If I'm already bent over like this and I just straighten up, that's an extension action, right? I don't have to lean back. I just have to be moving in that direction or moving in this direction for this to count. Okay? We got the idea with flexion and extension here. The place where you're going to begin to put this together is when you look back at your muscle chart And we'll look at that a little later today. There's 2 more columns in the muscle chart to learn by the time we get to the test. And that's the action column and the nerve column. We'll talk about nerves later today. But that action column is fairly straightforward. It will always include a joint. If we describe the action of a muscle, we're going to say that it causes movement at a certain joint, and we're going to describe movement like this. Now, certainly you've learned most of your joints by now, haven't you? Right? So you know the name of the hip joint, right? It's a ball and socket. That's what type it is. What is the name that we give this joint? Okay, the bone here is the os coxa, which means the bone called the coxa. But the joint is it is a synovial joint, but its name is, it is a ball and socket type joint, but its name is, there we go, the coxal joint. That's its name. That's like you keep saying, you're a human being. Yeah, but what's my name? You're a human being. What's my name? Well, you're a human being. Okay? Describe what type it is, but what's its name? There are 10 names that you must know. Those are on the blue handout. This is the coxal joint, right? We've talked a lot about iliacus psoas major, haven't we? Right? You know, they sit right here in the front. They come right down like this. They attach to the vertebra and the ilium here. They come down here. They grab the lesser trochanter, and when they pull, the bone does this. This coxal joint does this when they pull. Now, what just happened at the coxal joint here? Is this flexion? If it goes from here and we go to here, is that flexing or extending? Flexion, right? So if I say, what is the action of the psoas major? Well, you know where it is. You know which joint it crosses. If you can just tell me it crosses the coxal joint, you've got half the answer. If you can also tell me that when that pulls, it's a flexing action, that's the whole answer. It flexes the coxal joint, right? Gluteal muscles here in the back, when you pull that gluteal tuberosity, the bone is going to go backwards. These are going to be extensors of the coxal joint. And you look right down that last column in your pink handout, and you see the names of the joints, and there's very few of them. It's going to be either hip, knee, ankle, or the little things in the toes, the little interphalangeal joints. And then if you know what extension and flexion is, if you know all the rest of these movements, you can just think, well, if that pulled and this bone went that way, what's the name of that movement? That movement at this joint is the answer to an action question. So if you know the movements, if you know the joints, the action questions are just a lot of common sense, really. It comes right down to it. Okay. So, we've described flexion and extension. In describing this, here are sort of the rules that you want to use. And let me just kind of summarize that. Right? If you're on the limbs, the easiest way to do this, from the elbow down or the knee down, is just to say, is it bending or straightening? Right? Just use, is it bending or straightening? Because arms and legs can be in funny positions. But if you're in the torso, including the shoulder or the hip, then really use that concept of anterior and posterior motion. Okay? That's the best way to do that. Okay, let's look at a couple of other motions here. We did flexion and extension. Let's add to this now, abduction and adduction. Which of these two words gives a name to a muscle or two? There's two different words here. Which one of these becomes the name of a muscle? Ab or ad? Adductors, right? I always hate when I have to mark an answer wrong on a muscle quiz because somebody wrote abductor magnus. Okay, one letter makes a huge difference in the word. It's a different word if it's got one letter wrong or one letter difference. Now, most people know what abduction is, right? If you abduct someone, what happens to them? They take away, right? All of this abduction, adduction is a medial lateral motion. Okay, it's not an anterior posterior motion we've just described. That's flexion extension. This is side to side motion. Now, tell me which of these two motions is abduction. I move my arms like this, away from my body, or I move my arms back in toward my body. So if I'm doing this, what did I just do? Abduction. Take away, if I move the limb laterally away from the body, the midline of the body, right? That's an abduction. And then just think of the word add here, A-D-D, add, and add your arms back to your body. That's adduction. Take them away, add them back in. Probably the best example of this would be like jumping jacks. Did you ever do jumping jacks in PE in school at some point, right? There's no anterior posterior motion when you do this, right? It's all lateral medial motion. These are abductions and adductions, right? So the abduct is very obvious, take away. Adduction is, and adduction is moving back toward the midline of the body. Remember, they don't mean anything, right? Medial and lateral don't mean anything unless you picture a midline to the body. Now, this is a medial lateral motion, but there are other places where you can use this. It's real obvious when you swing your arms or your legs away, but you could also be moving your torso away from the midline, right? What am I doing right now? Okay, I'm abducting. If the midline is over here, I'm moving away from it, aren't I? And what am I doing now? Okay, I'm standing up again. I'm adducting. And if you just picture that midline, then I'm abducting, 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 adducting, 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 abducting, abducting, right? So, and the head is the same thing. If I move my head laterally, that's abduction. If I bring it back to the midline, it's adducting, right? And, yeah. So swinging, body, torso side to side. You can also see this in other body parts, like take your hand, for instance, where we talked about being able to spread your fingers where they meet your hand. Okay, that's a lateral medial motion, isn't it? In anatomical position. Nothing is going forward or back. And so what you really need to do is kind of like it shows here, just picture sort of a midline down the center of your hand, and if you're moving away, that's abduction. If you're bringing them back in, that's adduction. That makes sense? Okay, so abduction, adduction are these lateral kinds of motion. Muscles that are on the side that are going to be pulling the bone away from the midline are going to be abductor type muscles. The muscles here in your medial thigh are ones that pull in, right? They go from your hip to your thigh, and because they're positioned on the inside, they can't pull the bone out. They're going to be pulling the bone back in, which is why they're adductor magnus, adductor longus, adductor brevis. The location, whenever you've got a movement name and a muscle, the location is really critical to understanding that. Okay, so we've got these 6 terms. We've done flexion, extension. We see those are opposites. We've done abduction, adduction. Those are opposites. Now let's talk about rotation. Okay, I've already spoke of rotation briefly. We said that pivot joint is only capable of rotation. We described rotation as a spinning action, which it is. In your textbook, they illustrate it like this, and they use this bent elbow here in the picture because the arm out here illustrates that rotation. Sometimes it's hard. If I just rotate my arm like this, you can kind of see it. But if I bend my elbow and then I rotate, you can see that there is quite a bit of motion there, isn't there? My forearm is not rotating when I do this. The rotation is happening at my upper arm here, right? And basically you can describe, because you can rotate one direction or the other, one is described as medial, the other described as lateral. And basically this, again, the elbow thing here kind of illustrates that. If I rotate in such a way that the body part attached to the rotation is pointing toward the midline of the body, that's going to be a medial rotation. And a rotation that takes an object pointing lateral is going to be, or away from the body, is going to be a lateral rotation. So this would be a medial rotation. This would be a lateral rotation. You could do the same thing, just maybe where you're sitting. You can do this with your foot, can't you? Can you rotate your foot side to side? Right? You're actually rotating from your hip because your knee does not rotate, your ankle doesn't rotate. Those are hinging joints. But you can rotate from your hip. And if I'm rotating so that my foot is pointing in toward the midline of my body, that's a medial rotation. And if I was turning it so it was pointing out, that would be a lateral rotation. So, fairly simple type description. This is the body part that's rotating, right? This is just showing you kind of the movement more easily there. Okay, any questions with rotation? Got the idea? All right. Okay, so what have we got? We've got the abduction or flexion extension, abduction, adduction. We've got the two types of rotation. The last one, the sixth one here, is circumduction. Now don't confuse this with rotation. Like abduction and adduction are opposites. Rotation and circumduction are not opposites. That's why I've listed them on separate lines. Circumduction looks like this. And basically you want to think about when you have a body part that's moving in such a way that you're moving circularly or point your finger here and draw a nice big circle with your arm, right? That total motion is called circumduction. And it's really multiple motions. This is really a combination of flexion, extension, abduction, and adduction, right? If I do this, right? If you think if I'm drawing the circle, see the circle in four pieces, right? If I'm going from here to here as I start the circle, I'm doing two things. I'm going forward, right? And I'm starting to move away from my body, right? I was in here closer. I'm moving away, farther away. So I am flexing and abducting. When I get to this part of the circle, now I'm extending and abducting. I'm still getting farther away. Back here, I continue to extend, but now my arm's coming back toward me, so it's adducting. And then finally, the last sweep here is I'm flexing and adducting. I'm getting closer and going forward. But rather than mess with all that, they're just going to call this circumduction. And you can do it at many different joints. Here at the shoulder, it's real obvious. I can do it at my elbow, right? Which is actually two motions. It's the rotation that's going on up here at my shoulder and the hinging action. And my brain is clever enough that it can do that to draw a circle. I can do it with my ellipsoidal joint because it's biaxial. I can circumduct here. And I can even circumduct at this ellipsoid joint right here, right? I can do it with one finger too. I know, big deal, right? Okay, so circumduction can happen in all sorts of places. I can do it with my waist, right? I can circumduct. If you just looked at where my head is pointing, right, it's drawing a circle. Right? I can do it with my neck. Right? So you can circumduct in all sorts of places. Yes. Yeah. When you're moving something in a circle, we're going to call that circumducting. Right. Watch my hand as I circumduct. Yeah. Is there any spinning going on here? See my hand? Right? Rotation is this. And circumduction doesn't necessarily have it. You could, I guess, be rotating and circumducting if you wanted, but that's way out there. But circumduction does not have any rotation to it. That's why these are different. They're not even opposites of each other. They're just two different things. All right? Now, these are the movements that are going to be happening everywhere. You're going to use these all semester long. When we do the upper limb, when we do the torso, all the way through, we're going to be talking about these various kinds of motion. So you need to know these. There are some other movement terms that are going to come up in this class. Some that apply more to a certain area or another area. For example, there are two. If you look at the last part of your handout, there are two pairs of terms that are only found in the lower limb. And we want to take a moment to describe those. Okay, right here, the movement's called dorsiflexion and plantar flexion. Your foot, where your foot meets your leg, it's kind of an interesting area because there's more like a T here. Because the foot sticks out in the back, it's not like your hand. Your hand doesn't have a heel sticking out and a right angle to it here. But because you've got something that sticks out in the back and sticks out in the front, this isn't just flexion and extension here. They use these two words for that forward-backward movement of the foot. And to make sense out of these, you should be able to label the two surfaces of the foot. The underneath surface that you stand on, and what we would think of as the back surface, the top surface of the foot. And the deep side, the underneath side of the foot, is what we call the plantar surface of the foot. Some people describe this as the sole of your foot, S-O-L-E. If somebody says, get ready, here I come, plant your feet, right, what do? Right? The part of your foot that sits on the ground where the plants are, that's your plantar surface of your foot. The back side of your foot would be called the dorsal surface of your foot. Just like the dorsal surface of anything is its back. So how do I make sense out of this? Well, if this is the dorsal surface and I raise my foot, the angle between my leg and the dorsal surface of my foot is getting smaller, isn't it? And that, of course, is a flexing activity, isn't it? So I'm going to call this raising my foot dorsiflexion. All one word. Walk around on your heels, right? Have you ever done that? Walk around, keep your feet, your toes and your feet, the front part of your foot off the ground, just balance on your heels. That's dorsiflexing. Every time you take a step, when your leg is ready to swing through to take the next step, you dorsiflex your toes and your foot so that you don't drag them on the ground, right? You dorsiflex it to get it up so that you heel strike when you take a step, right? You do a lot of dorsiflexing when you walk, just to keep so your toes don't drag on the ground. Now, the opposite of dorsiflexion is plantar flexion. Plantar flexion, two words. This is one word, these are two words. And it's not real clear why anybody ever came up with this, other than maybe if you continued the midline of the leg down here, as you bring your plantar surface down to where that midline would be, that would be a flexing activity of a sort. So dorsiflexion, plantar flexion. I always think, in my head, I think plantar flexion points your foot, right? Pointing plantar flexion. So that movement. Ballerinas and ballet dancers and gymnasts and divers all know about how important it is to point their foot in their athletic endeavors, right? So they look very streamlined. So dorsiflexion, plantar flexion, only at the ankle. Only at the ankle. Okay? Raising your foot and pointing your foot. Now the last two are when your foot at the ankle moves side to side. This doesn't happen very often and not in normal everyday life. If you're walking on a very uneven surface, if you're walking on some grass that's kind of uneven, or a cobblestone street, or you're just walking out in the hills somewhere where the ground is very uneven, your foot is going to be tipping side to side just to meet the contours of the ground and keep you stable. Those two motions are called inversion and eversion. It's a lateral. This is more like abduction, adduction, kind of. We call it inversion and eversion. The way to picture this so that the words make sense, because this kind of says in and this says out, doesn't it? Like an exit. This is in, this is out. Look at the sole of the foot, the plantar surface of the foot, and when you tip it from side to side, does the plantar surface face in toward the midline of the body or out away from the midline of the body? Inversion, the foot is tipped pointing in. Eversion, the foot is tipped pointing out. Which one of these two does your foot have a greater range of? Do you have more inversion or eversion? Which way can you tip your foot farther? Inversion, right. You can do about 10 times as much inversion. You know, just standing here, I can almost put the side of my ankle on the ground because my foot just tips in so far. This is why most ankle sprains are inversions, because your foot tips in very easily. It doesn't tip out, and you could do this. Do you remember these two lumps? What are these called here, the bony lumps here? Malleolus, which ones? Medial and lateral, right? Medial one is a short little thing belonging to the tibia. The lateral one is that distal end of the fibula. And it really comes down so far that it prevents your foot from tipping out. The lateral malleolus comes down maybe another inch farther than the medial malleolus. So most people can't evert their feet very well. Inversion is fairly easy. Okay? So sole of the foot faces out. Laterally, that's the eversion, okay? Sole faces inward. Medially, that's inversion. Okay, so how are we doing? You okay with these? Got the idea? Want to be able to apply them. Let's do this. You've got a handout that I gave you that I think will be helpful here. Okay, it looks like this, right? You have a handout there that looks like this dancing woman. Okay, so what I want you to do is take a few minutes here and see if you can put the motion names to the letters in the picture. Now here are the rules. Here's the guidelines. Okay, you're going to label each motion. Each letter here represents an emotion. Skip letter A and M. Those are two motions we haven't talked about. Skip A and M. You may use the motion words more than once. You may use them more than once. If an arrow is right next to a joint, that arrow is saying that the joint is doing what the arrow shows. If the arrow was bent, it's saying that the joint is bending. If the arrow is straight, it would say that the joint is straightening. If the arrow is not right at the joint, it's probably showing the direction that the whole bone is moving, like letter K. Letter L is right at the joint here, but letter K is just showing that the arm is coming closer to the body here. So there's two different kinds of arrows here, ones that are right at the joint and ones that are just showing that an object is moving. So I'm going to give you about 5 minutes or so. See if you can label all of these, and then I'll give you the answers in just a moment. Yeah, it's this. Yeah, it's not at the elbow. It's showing that the arm is going like that. Okay, about another minute. Okay. Just put down your best guess on this. You don't have to study this or you don't even have to get them all right now. Just do your best.